Hi everyone, my name is Jeffrey Zablocki. In class we've been talking about design patterns, so I put together this presentation to go over what the private class data pattern is. From reading our textbook, Design Patterns Explained, we've learned that different design patterns are usually comprised of the following elements. We have intent, problem, solution, participants and collaborators, consequences, and then implementation. And then usually to go along with everything, you can find some sample code to demonstrate how the different design patterns work. So the intent. Well, the private class data pattern is designed to manage who has right access to different attributes in a given class. It wants to keep the data separate from the consuming methods, and it looks to encapsulate the class data. Where does the problem come from? Well, it's usually because a class's attributes are exposed to change when they should not be. A programmer can get in and start working on a given module, and whether they accidentally or incidentally do it, they can change different attributes, and then other developers are unaware of this. So when they go to use the variables that were affected by other developers, they don't realize that the integrity of the data has been lost, and what they think they're using is really a different value. So to go along with this, the class state also needs to be protected by minimizing the visibility of the attributes. So what's the solution to this problem? Well, the problem we discussed involves one main class. This main class is going to include all your variables as well as your different methods. So the solution which the private class data pattern solves is it goes ahead and it takes your main class and it divides it into two classes. You're going to have a data class and a main class. And the main class is going to hold all of your methods. And then so the main class is then given an instance of the data class in order to be able to use your data. I promise this will become more clear later on. So as I mentioned, we're going to have two different classes. The main class, which contains the methods, that's going to consume the further information from the data class, and then the data class is only going to contain the data and the variables to be used by the main class. It's important here that methods and other things don't start muddying up the data class. It really is supposed to just encapsulate the data, and then you're going to keep the logic in the main class. So what's the consequences of implementing this design pattern? Well, as mentioned, we're going to take one class and we're going to turn it into two. So it adds more modules to the project. Now, before, where working in one main class, you were able to just call a variable whenever you needed it. Everything was confined to the scope of the module. You didn't have a problem when trying to use data. Well, now you want to use data that's held in the data class. So in order to retrieve any of this information, you're going to have to use a get method. And to go along with this, if you want to change any data, you have to use a set method. Now the reason this is great is because a lot of times the data is not meant to be changed, it's only meant to be consumed. So if no get or set method exists, then that data cannot be retrieved or changed. So this allows a developer to put in place what he wants to happen. If he doesn't want anybody to change a variable, then he just simply does not create a set method in the data class. And then also, as a result of implementing this pattern, if people are working in a multi-developer environment, then the main class and the data class can both be worked on simultaneously by different people because they're two separate modules. So how is this going to be implemented? Now, we mentioned we're going to take one class and we're going to turn it into two. So before, where you had your main class that had everything, you're going to take this and break it out, and you're going to create a data class. This data class is then going to have all the attributes that should be hidden are going to be moved here. Then the main class is going to create an instance of the data class, and now all the other methods that should be consuming this data are going to stay over here. And then the attributes are going to be exposed through the get method as mentioned before. And then in order to change, once again, the developer is going to have to implement a set method. So what's this look like? So here you go. You see, this is before the private class data pattern is implemented. You have your main class, you have all your variables, attribute 1, 2, and 3, and then you're going to have various methods to go along with that. So one thing that might come to mind is you're going to say, well, the variables are private. So, if someone creates an instance of the main class, they're not going to have access to those variables anyway to change it. But even though they're private, thinking about it from the point of view that a developer comes in and they're working on the main class and they're adding different methods, they have access to attribute 1, 2, and 3. They can go ahead and write a method that ends up changing the data in one of the attributes, and then further along the line another developer's method gets affected because the data was changed and they were not aware of this. So the example I'm providing here shows that even though you set the variables to private, they can still be affected, and that's why the private class data pattern is still useful. So after you break this out, you're going to see now you have two classes, a main class and a data class. So the main class, really, that's just going to have the different methods that you want to use the data class with. The data class, then you move all your variables down below, and then you're going to have the different get methods as evidenced here. So now anything you want to do with the different attributes 1 through 3, you're going to just take method 1, do this, method 2, do that, and then they'll call the get methods to be able to add, subtract, display, whatever you need to do with the data. And then it's important to remember here that when working in the main class now, you're only using an instance of the attributes. You're not using the actual values. So I learned best by doing. So what I did is I went ahead and I created a example in code, and then hopefully this will be able to demonstrate what we've talked about a little easier. So without further ado, we're going to break apart from the PowerPoint and we're going to move over and look at some sample code. Okay, so as I mentioned, I learned best by example, so I went ahead and I put together a sample application that's going to demonstrate both before and after for the private data class pattern. I am personally a VB programmer. I do Visual Basic Language every day at work, so that's what I wrote this application in. I know many people are Java programmers or C#, but even if you're not a Visual Basic programmer, I think this should be pretty easy to follow along with. So what I have here is a sample GUI that's going to demonstrate the visually so you can see the effects of the code. I am a baseball fan, so this application is baseball related. And if anybody's wondering, Baltimore Oriole fan. So anyway, I digress. This GUI go ahead and shows that I have a player, which I just put my name, and I also have some season data. That this on load of my GUI, this just simulates pulling information from a database. I actually hard-coded the data in, but it's the same thing. So you can see I have throughout the season 21 hits and 75 at-bats, and I have 8 walks. Then I have 2 buttons that are going ahead and they will calculate the average or on base percentage for the player. And then just to demonstrate what's going on in code behind the scenes, I have a button down here that when you click it is going to show the different data that's saved in the database. So as you can see, it matches the data above: 21 hits, 75 at bats, 8 walks. So let's go ahead and get into the code. So I'm going to close out of here. So this is the code for the GUI, the page behind the code behind page. On load, I go ahead and I'm calling an instance of class main. As we talked about in the presentation, before you implement this pattern, you're going to have one class. And so to keep it simple, this is class main underbar before. So I go ahead and I pass into it the 3 different values from the database. I have my hits, at-bats, and a little further over here I have walks. And this just simulates pulling information from the database. In a normal scenario, I would write methods to query the database and then use that to pass into the class. And then below you can see that I have button clicks here. I have one that's going to go ahead and calculate the average, and then it displays it on the screen. And then I also have another method that's going to calculate the on base percentage, and then that will display it to the screen. So when we call into my class main before, what's happening? So on initialization, I take the information that was passed into me, and I'm going to go ahead and save that into the variables we have. I also have different, just to go along with some proper coding standards, to pull the information out of this class, I wrote get methods, get hits, get at bats, get walks, which we'll actually see in the after, but they can still be used here, and you'll still see why there can be a problem. So I use those return back the data that is saved into the database. Then I have a couple methods. I have calculate average and I have calculate on base percentage. I do the necessary math calculations here and return back the result. So everything seems fine. So let's go ahead and run the code again. And as you can see, we still have the 21 hits, 75 at bats, and 8 walks. I'm going to click show attributes, and it still shows the information saved into the database. I calculate average. Now this is done by taking hits and dividing by the number at bats. So I have a batting average of 280. It's not bad, not bad. And then, so let's see what my on base percentage is. This is done by adding walks to the hits and then still calculating by the at bat. So on base percentage is always higher than your average. It will always be higher than your average, unless you have absolutely no walks. Then it would be equal to your average. But the important thing to remember here is it can never be less than the average. So I'm going to go ahead and click calculate on base percentage, and I have a 349 on base percentage. Not bad. I was never a guy to take much walks in my baseball career. So no matter how many times I calculate average, I'm going to go ahead and keep clicking this, and I'm going to keep calculating my on base percentage. The number's the same. I can click show attributes again. The data has never been modified. So I'm going to close out. So let's say down the road, a few months later, somebody discovers an error or they want additional features added to the application. So they're going to go ahead and they're going to come down and they're going to go ahead and want to add another function. So let's say they want to add public function, and we're going to call this bad method. And we're going to call this bad method because it is going to change data behind the scenes without us knowing. So I'm going to go ahead, do my try catch, because I have that ingrained into my head to always do a try catch. And then let's see, here I'm just going to go ahead and take my variable at bats, and I'm going to set it equal to at bats times 2. So all this method did, now of course let's say we'll probably have some code here, more code here, something else here. So just so you don't think the sole purpose of this method is to come in and just break stuff, it actually accomplished something, and it did so, but somewhere along the lines someone set the variable equal to something else and changed the integrity of the data. So let's see, say calculate on base percentage, and they decided that this method should go here. Okay, so I'm going to go ahead and run the code again. So we see we have 21 hits, 75 at bats, and 8 walks. If I go ahead and pull the information from the database, it should always match. 21 hits, 75 at bats, and 8 walks. I calculate the average, 280 as we saw before, and calculate on base percentage, 349. Same thing. But if I go and click show attributes, at bats changed. It just doubled. And that's because the bad method we wrote changed the integrity of the data. Now, the average and on base percentage look okay, but if we ever come and calculate the on base percentage again, it changed. And remember, before I said on base percentage cannot be lower than the average. Well, now it just dropped by a lot. So here the calculate on base percentage, all of a sudden the data has been affected. It's not returning the right result. But why that happened? Well, as we saw, the data was affected by some other developer coming in, changing the variable, inserting a method. And honestly, another way to look at this is the bad method may at one time been a good method, and then somebody came and added to that method and they changed the data there. So the code for calculate on base percentage may never have changed, but a method within it did and changed a variable that didn't need to, and now we're seeing the effects of it. You can click show attributes again and you see once again the data changed. So now we're all the way to 300, and every time we click this button it gets lower and lower and the data keeps changing. So we need a way of prevent this, and that's where the private data class pattern comes into play. So we're going to stop here and we're going to transition over to the after. Okay, so before we talked about the before implementation of the private data class, now we're going to talk about the after. You can see here we have the same GUI as before. We have the hits, at bats, walks, we have the buttons, we have the attributes. If I go ahead and click these, you're going to see the same functionality as before. The only difference now is that the structure that's making this happen is different. So let's go ahead and take a look at the underlying code. Close out of here. So here we have the code page for the GUI. We're instantiating the class main after object. Now you can see we're going after something different. So I instantiate that object. I'm going to pass in the information that I would have theoretically pulled from the database, same as before. The only difference is now when we get to the class main after, we see that this in the instantiation of this class is actually now going and getting an instance of the class data class that we talked about when going through the PowerPoint. And it's going to take the hits, at bats, and walks and pass this information into the data class. So if we go ahead and look at that class, and we'll come back to the main class in a second, we're going to see we go ahead and set our variables. We have our hits, at bats, and walks, and they're being set just as in before implementation, but now it's all happening in an encapsulated data class. And if I scroll through, I go ahead and I see my get methods. I can get hits, get at bats, and get walks. And that is the only thing that is in this class. Notice I have not put any set methods, so there's no way that anybody using this class is going to be able to change the values of the variables. And then in development, nobody should be coming into this class and tinkering around and resetting variables. That just would be bad practice at a company. So now that we see that this class is actually very sparse because this is the only variables we have, we're going to go ahead and go back to class main. Here I have my same methods as before, calculate average and calculate on base percentage. But notice the difference. Now instead of calling the actual variable, I'm calling a get method, and this get method is what's going to retrieve me the value of my given variables in the data class. So I go ahead and I can do average by getting hits and dividing them by getting the at-bats. And down on base percentage, I can do the appropriate calculations. So we'll go back and we'll run the code. I'll show attributes. Everything looks fine. Calculate average, on base percentage, click to show attributes. Nothing's changing, everything's done right. So what if I come in here and I'm in my class main now, and say I want to try and write a bad method again. So I'm going to go ahead and do public sub bad method. Oops, sorry. Put my try catch in there. Well, I actually don't even know what to do right now because there's no way I can do this. If I want to go ahead and say I want to do the get hits, and I want to change my hits this time. I'm going to go ahead and take my baseball object of my data class. I'll get hits, set it equal to my object get hits times 2. No, that's an error because the get method will only retrieve you the value. So if I want to do set, nope, I don't have it, so I can't do it. So what you can see here is there's nothing I can do right now that's going to go ahead and change the integrity of the data. It's all protected, being encapsulated in the data class. If I wanted to be able to change those values, I'd have to add a set method to the data class. And at that point, I could go ahead and write a method that would change the value. And of course, now you're leaving open the opportunity for the data to change behind the scenes, but at least now you're allowing it to happen on something that it would be appropriate for the data to change. Before, if I'm pulling out information on hits, at bats, and walks throughout the season, and I want to do calculations, we're looking at this at a set point in time. That data should not be changing. But like I said, now say I want the purpose of this application changes, and this application needs to be used throughout a live game. Then perhaps it might be necessary to change data. But if I'm simply looking after a game, there would be no reason to be changing the data. The data is not changing. So hopefully these examples made it a little clearer. So now that you were able to see a example in code, I hope that the private class data pattern is a little clearer and easier to understand. So I just want to recap what we talked about. So the class variables in the private class data design pattern are encapsulated to a single data class object. This will go ahead and separate the data and the methods that use the data. And what this does is it allows us to control the right access to the variables. This way the integrity of the data is not compromised, and developers can feel confident that when they implement an instance of the data class, they are having the actual data and it has not been touched. And the great thing about this pattern is it's generic. It can be used in pretty much any object-oriented language. So regardless of what kind of developer you are, you can go ahead and implement this in your code. So here are the references that I use when putting together my project. If you have any more questions, feel free to respond to the thread and ask me, and I hope this was helpful. Thank you.